Before we do some 7.6 multiplying polynomials, let's have a little bit of a friendly reminder about two-digit multiplication. I'm going to move in and get closer here just so that my multiplication is not too sloppy. So here on the left side, set up a 2 by 2 digit problem, and then on the right side, let's break 24 into 20 and 4, and then 30 and 6. So when you multiplied, you always dealt with as ones first, this 6 over here. Well, 4 times 6 gives me 24. Then you move on to 6 times 20, and so that's 120. But you'd also have to keep in mind that 12 and 2 gives you 14. So, then once you move on to the next step, you'd be like, well, 6 times 24 is 144, but I'm going to move on to the tens place where this 3 is at. So I'm going to sneak a 0 in there as a placeholder. And I'm going to do 3 times 4 to get 12. And, make sure don't forget about my 1 that I have to hold up here. And then 3 times 2 gives me 6, plus that 1 gives me 7. And once I put all this together, I get 864. And I just added that left to right because I knew nothing would carry. But really that works out nicely because, really, it's a distributive property. That's what's going on. And if I look at 20 plus 4 the way I have it written, at some point we had to do our 20 times 30. At another point we had to do our 20 times 6. At another point we had to deal with 4 times 30. And then at another point we had to deal with 4 times 6, which gave us that ones place that we started off with. And the reason I like this is because it helps me see that if I broke it out in parentheses, all this stuff is going to end up hitting each other, to where I would do 20 times 30, 20 times 6, 4 times 30, 4 times 6, and then really put it all together to come up with that. But you don't really see that this is what's going on. So just kind of map this out, and we're going to sketch that for a friendly reminder about multiplying. Now, the distributive property, we get used to just seeing one thing out in front, distributing to a couple things on the inside, but really, we could have multiple things going on in each pocket of these parentheses. So FOIL is a method to distributing, and the letters FOIL are an acronym that stands for first, outer, inner, and then last. So FOIL. Now, I do and I don't like this. I'd rather you be able to see it than just be kind of robotic about it and memorizing things. But the first term shows up here. And so for dealing with the first, we match up the first two terms there. And most commonly, they show this connecting x to x. Now, when I would do x, I have to remember that these parentheses are multiplying. So my first would give me x times x, or just x squared. I would have my outer, which would be x times negative 2. So I'm going to write minus 2x. And since it's first, then outer, and then I'll deal with the inner, depending on how people represent it, they're either going to show it here or here. The book shows it connecting here. So I have 3 times x. And then I would have to move on to my last, which would be 3 times 2 with subtraction because there's a minus sign there. And when we simplify, the nice thing about the FOIL method is it puts the x terms, the like terms, back to back sometimes. And I'm going to write x squared plus x, combining those two to get minus 6 at the end. And that's how you would FOIL. Now this is almost the exact same example. So I'll pinch and zoom in. We'll just do a few different examples because this is kind of like a plug and chug type problem where you just go about it. Now, first we're going to have the x terms connect. So this is the quantity x plus 3 times x plus 2. And x times x gives me x squared. I move on to my outer. Well, I see x hitting that 2, so I have plus 2x. Then my inner, 3 times x. And then I deal with my last, which is 3 times 2. And that's starting to look like a line, so maybe try to keep it a little bit more like an arch if you can. So 3 times 2 gives me 6. Putting this all together, I get x squared plus 5x plus 6. Now when I did these types of problems, I always kind of like to look for patterns in them. So I'm like, well, that's kind of weird. That was x plus 3 times x plus 2. Here's x plus 3 times x minus 2. And when I compare the two, I had a smaller x term than I did here. Well, that's because they were both being added. And then also I had subtraction going on here. Well, that's because one of the minuses showed up, whereas both of these terms were positive. So just as you look for patterns in these, it'll really strengthen your understanding of the FOIL method overall, to where later on you're not going to be memorizing the fact that you're doing FOIL. It'll just become like muscle memory, hopefully, and you're just simply distributing and seeing it all in multiple steps. My first, x times x gives me x squared. Now you're probably like, well, I guess it's always x squared, but there will be problems where you'd have x squared times x to the fourth. It's all dependent on what you have showing up first there. So back to that. X times x was my first. Then my outer is plus x times 7. But I don't even think about it that way. I just see, whoops, 7 times x. So I always like to deal with the constants first. Then my inner is minus 5x. And then lastly, 5 times 7 is 35. And I see one subtraction symbol. So I have x squared plus 2x, once I simplify, minus 35. Now, if you have your textbook, you can always flip to the back and compare your problems with the odd numbers in the back of the book. But as you're doing these, and you want to make sure you have them correct, these ones are actually pretty easy to type in Wolfram Alpha, especially because there's no exponents or anything involved. First, outer, inner, last. So when I deal with my first, I get x squared. I deal with my outer, it's going to be minus 4x. And then I move on to my inner with the 3x. And then 3 times 4 gives me 12 for my last, and I subtract it. Combining like terms, I get x squared minus x minus 12. Did I just do the same problem twice? Feels like I did. Nope. I think we're good. Okay, we have a few more examples, and then you'll see that this one's pretty much the same. So make this first one an OYO problem that has just the M. Oh, how'd that happen? Has the M business. So I'll put the answer up in a moment. You could also look for patterns. You'd be like, well, 4 and 5 gives me 9, and here's that 20 from 4 times 5. Let's see. Let's slow down for this next one. And the reason we'll slow down a little bit is just to say that we have different things going on. Well, this would really be 2y times 6y. And I'm writing that off to the side just to help us see that, 2 times 6 would give me 12y squared. And then my outer, 2y times 7, is going to be minus 14y. My inner, 3 times 6y. Well, 3 times 6 is 18. Gives me that y there. And then last, 3 times 7. So it's going to be minus 21. And you're always going to want to maybe do these a couple times, even for the same problem, to make your minuses and your positives all accurate. So then when I simplify this, I have 12y squared plus 4y minus 21. I box it. Okay, so this last one that I have here, make this another OYO problem, and you got a couple moments before I start it. Check to see if everything agrees with me. Make sure that you know that that's an A that's written here. So 12a squared minus 7a minus 10. Now here's where they get a little bit more challenging. And this is where you kind of want to walk away from the FOIL method. As I learned these problems, I always knew, the first term would have to hit every single thing that showed up in the other parentheses. And the same term that it was buddied up with would have to do the same. So when I did these, I did them gradually at first. I was like, okay, 4x times 2x squared becomes 8x cubed. 4x times minus 5x becomes minus 20x squared. 4x times 3 becomes 12x. And if I look at the degrees and how they decrease, it'll help me be like, well, then they would also count on from 3 to 2 to 1, because this x term is adding one more variable to it. So it's 8x cubed minus 20x plus 12. Now I have to move on to that 9 term. Let's see how I'm doing with space here. And kind of running out of different colors, so I hope you don't mind me repeating it again. Here's 9 times 2x squared to get 18x squared. 9 times 5x gives me minus 45x. Now notice that my colors are just because of the order I did this in. They're not going to match up when I combine like terms. Then I have 9 times 3 to get 27. I scan through and I'm looking for all the x cubed terms, and I only see 8x cubed. I scan through and I'm looking for all the x squared terms, and I have minus 20 plus 18, which would result in minus 2x squared. I'm looking for all my x terms. I have positive 12 minus 45. Now these are bigger numbers, so you could pull out your calculator to do these, but 45 minus 12 is 33. And I have to make sure that the negative part wins, so minus 33x. And then I only have one plain old number, so there I go. Now this is even more challenging, because here I had 2 terms hitting 3, which resulted in 6 total terms. But this would be 3 terms. Maybe I got like 9 terms going on here. Let's check this out. So I'm going to see y squared hitting 6y squared. I'm dealing just with this term first. 6y to the 4th. Then y squared times 3y gives me minus 3y cubed. Then I have y squared times 1, so this is plus y squared. So that was only when I dealt with that term. Next I'll have this 2y hitting everything. So minus 2y times 6y squared is going to be minus 12y squared. Minus 2y times negative 3y is plus 6y squared. A little bit more room for error on these, by the way. Then I have negative 2y times 1, so I got minus 2y. Then I'm going to have to deal with this 5. So 5 times 6y squared is going to give me 30y squared. Hopefully I have enough room here. I want to keep this neat. 5 times 3y gives me minus 15y. And then 5 times 1 gives me plus 5. I really don't like to go into a new line there because it gets pretty sloppy. Now 6y to the 4th. Now really that should be the only term that I have showing up to the 4th. So the more confident I get with, I could be like, well, I'm definitely going to only have one over here for this particular problem. And there's a reason for that. So now I scan through all the y cubes, and I only see 1y cubed. And I'll be honest with you, that doesn't seem very reasonable to me. And that helped me realize that when I did get this 12y squared term earlier, that was connecting these, that should have been cubed. So maybe you caught that. If you did, good work. And you can tell me to give you a bonus point, and I maybe will or probably won't. Okay, so here we got minus 3y cubed, minus 12y cubed, so I'm going to write minus 15y cubed here. Sorry about that, folks. Now I look for the y squared terms. I see a y squared, 6y squared, 30y squared. Now I'm kind of lucky. These all ended up being positive, so I'll just combine them all in a go. So that would be 1, and 6 is 7, and 30 gives me 30y. Let's sneak that exponent back on there. So that they all agree. Okay, 30y squared. Scanning through for my terms that show up with y, I get a minus 2y and a minus 15y to give me minus 17y. And then lastly, just that plus 5. Now let me model what happened there. Made some mistakes, didn't I? So I should, go through and check it. This showed up there, so we're good there. I'm going to slash through it just as I do it on this problem. Minus 3y minus 12y became minus 15y squared. 1 and 6 gave me 7, and 30 gave me 37y squared. Man, I'm falling apart today. And then 2y and 15y gave me a minus 17y, and then plus 5. So it's definitely a good thing I checked this one because I really messed this one up. Sorry about that. This will be updated in future edits. So see how you go with those. 7.6 multiplying polynomials. That's the homework assignment that goes with it. And it's a distributive property. It helps to think about multiplication and foiling and all that to get really rote with these, to where you can just drill through them.